Welcome to quantitative aptitude video on permutation combination from careerright.com. Like probability, this is considered a tough topic by many. Placement tests, job interviews, bank MBA and other exams always set 1 to 2 sums related to permutation and combination. Today we will see how to easily and quickly solve sums related to it. Practice questions are available on careerright.com, which has practice tests as well as 1000 plus aptitude questions. So let's start. Before going to the formula of permutation and combination, let us take a look at some few basic things that would be very useful to solve sums related to permutation and combination and also understanding its formula. First is the concept of factorial. Okay. Now what is a factorial? Whenever you write something as write a number as for example, if you write 5 factorial, this is the symbol for factorial. Okay. So if you write something as 5 factorial, that means that it is 5 into 4 into 3 into 2 into 1. Okay. So any number you can write as factorial, right? You can write 7 factorial. Value of 7 factorial would be 7 into 7 minus 1 6, 6 minus 1 5 into 4 into 3, you will continue up to 1. You can write 108 factorial also, that would be 108, value of it would be 108 into minus 1, 107 into minus 1, 106 up to 1. So if there is a number n and if we express it as n factorial or if we write n factorial, then its value will be n multiplied by n minus 1 multiplied by n minus 2 up to 1. Okay. This is the concept of factorial, right? Now let us move to another concept which is related to factorial, okay, and which is also related to permutation and combination. If say you have say 7 things, okay, if you have 7 things and if you want to, let us see, these are the things 1 2 3 4 5 6 and 7, and if you want to arrange these 7 things in one line, okay, in a single line you want to arrange these 7 things. So in how many possible ways can you arrange these 7 things? Very easy. When you want to arrange these things into single line, you can arrange them in 7 factorial ways. So if you have 10 things and if you want to arrange these 10 things in a single line, you can arrange them in 10 factorial ways. Okay. Also, this is like arranging in a single line. So we have, for 7 things we have 7 factorial, for 10 things we have 10 factorial ways. So for n things you will have n factorial ways. Now instead of a single line, we want to arrange it in a circular pattern or in a circle. So that means we have to arrange the 7 things 1 2 3 4 5 6 and 7 in a circle. We have 7 things. If we want to arrange these 7 things in a circle, then we can arrange them in simply 7 minus 1 factorial ways, that is nothing but 6 factorial ways. 7 minus 1 is 6, 6 factorial ways. If you have 10 things and you want to arrange these 10 things in a circle, you will arrange it in 10 minus 1, 9 factorial ways. So we can say if we have n things, we can arrange these n things in a circle in n minus 1 factorial ways. Okay. See how easy it was. Just remember, factorial means what? If we express any number as factorial, we can write it that number minus 1 multiplied by minus 1 multiplied by number minus 2 and so on. So 5 factorial is 5 into 4 into 3 into 2 into 1, up till 1 we have to go. Again, if there are n number of things and we want to arrange it in a straight line, arrange them in a straight line, we can arrange them in n factorial ways. If we have n things and we have to arrange them in a circle, we have to arrange them in, we can arrange them in n minus 1 factorial ways. Okay. Now these are some basic things that you needed to know. Now let us move on to the formula related to permutation and combination. We have permutation and we have combination. C comes before P. Okay. Now there are 2 concepts over here. First is to select, right? First is to select. And what is second? Second is to select, right? For select and arrange. So there are two concepts that you need to understand. There are two things when we talk about permutation and combination. The first is just select. Second is select and arrange. Okay. Now select has C into it. So select must be related to combination, right? C. So combination means to just select. Okay. Combination means to just select. Always remember this. Combination means to just select. So select and arrange means what? Select and arrange means permutation, right? But obvious, if there are two concepts, permutation and combination, and we have two things, select and arrange, then if select is combination, then select and arrange will be permutation, correct? Combination is select, only select, just select, right? Now combination is expressed as, let us see how to do that. Say you have n things, okay? You have n things in a box. Out of that you want to select r things. You have a box, right? You have a box over here and you have n things in this box, and out of that you want to select r things. So what do we have over here? We have n things, okay? Out of that we have to select r things. What is select? Select means combination. Combination starts with C. So NCR means we have n things and we have to select r things out of those n. Okay. Now r can be less than n also, equal to n also. For example, you may have 5 things in this box and you may want to select one thing or two thing or anything like that, or you may want to select all the 5 things, right? So NCR means is the formula for combination. NCR is formula for combination. And what is the formula? We have n. So write n factorial. We have r. Okay. So write r factorial. And there is another term which is nothing but n is greater than r. Okay. So n minus r factorial. Right. This is the formula for combination. See, very easy to remember. NCR. Okay. Whenever we have n things in a box, we want, out of that if we want to select r things, then what will be the formula? It would be n things in a box. We want to select r things. Select means combination. So we'll write C over here. NCR is nothing but we have n, so n factorial divided by we have r, so r factorial, and again another term below, that is n minus r, because n is greater than r, right? This is the formula for selection or combination. Then what will be the formula for permutation? Okay, permutation starts with what? P. We have n things. We have to first select r things and then arrange them. What is the formula for selection? N factorial upon r factorial into n minus r factorial, correct? And we already know that if we have say r things and we want to arrange r things, if we want to arrange n things, we can do it in n factorial ways. Same way over here, if we are selecting r things and arranging these r things, that can be arranged in r factorial ways. So r factorial gets cancelled. What do we get? N factorial upon n minus r factorial. Okay, so this is the formula for permutation, NPR. See, you just need to remember formula for combination, and we know combination is select, permutation is select and arrange. So take select, multiply it by arrange. Arrange is nothing but arranging r number of things, that is r factorial. So r gets cancelled and you get the formula. So there is no need to remember two formulas. You can derive permutation formula right from combination formula. Just remember, combination is select, permutation is select and arrange, right? Very easy. Using these formulas, we can solve all the sums related to permutation and combination. Again, before going to the sums related to permutation and combination, I would like to tell you one small thing. Now, what have we learned? We have seen the formula for permutation combination and we'll use it to solve the sums. However, some of the sums can be solved by simple logic also. Okay, we are going to see how do we solve sums related to permutation and combination by simple logic also. Okay, not always we'll need the permutation and combination formulas. Most of the time we'll try to use the formula, but we can also solve most of the sums by simple logic. Why do we need to learn how to solve by simple logic? Because in exam sometimes if you don't remember the formula, we can try to solve the sum by this simple logic or common sense. So we'll try to see both the ways, we'll try to develop both the ways. It is much better to have two weapons in our hand while going for exam. Okay, so let's move on to question number 1. In Daya's bag there are 3 books of history, 4 books of science and 2 books of maths. In how many ways can Daya arrange the books so that all the books of same subject are together? Now let us see how to solve this sum. Over here, do we see the word select? No, so combination would not be a part of it, but we see the word arrange. So permutation can be a part of this, but this is not select and arrange, it is only arrange. So instead of using permutation formula, let us use the normal factorial. We know that if we have n things, we can arrange them in n factorial ways, correct? So let us see how to solve this sum using simple logic. Now what are they saying? There are 3 types of books. There are 3 books of history, there are 4 books of science and there are 2 books of maths, correct? Now what they want is that Daya should arrange the books so that all the books of same subject are together. Now how to achieve this, that all the books of same subject remain together? If we add all the books, what do we get? 4 plus 3 is 7 plus 9. There are total 9 books, and if we try to arrange these 9 books, we'll arrange them in 9 factorial ways. But what will happen is that between maths book, science book might come or history book might come. So this would become difficult. So we cannot go by this way. So what to do in such cases when we want something to remain together always? Very, very simple. Consider this as one entire group. Okay? Consider this as a second group. Consider this as the third group. Now instead of having 9 separate books, we are just having 3 books, 3 groups. Okay? These 3 groups can be arranged in how many ways? Simple, 3 factorial ways. So whenever you are arranging the groups, okay, what will happen? You can arrange them as 1, 2 and 3, or you can arrange them as 1, 3 and 2. So entire group moves. Individual books don't move. So the entire group moves. So we are keeping all the books of same subject together. Okay? 3 groups can be arranged in 3 factorial ways. Now, in each group there is not just one book. In each group there are more books, multiple books. In one group, that is the first group of history, there are 3 books, right? 3 books of history. These 3 books of history can be arranged within themselves. This is 1, this is 2, this is 3, and this is the entire group. Okay? In the entire group of history, we have the first book, we have the second book, we have the third book. It can also be arranged as, in the entire group, first book, third book, second book. It can also be arranged as third book, first book, second group. Okay? So there are various ways to arrange also within the group, right? So in the group there are 3 books. So in how many ways these 3 books can be arranged within themselves? For the history group, there are 3 books. So these can be arranged in simply 3 factorial ways. For the science group, there are 4 books of science which can be arranged in 4 factorial ways. For the maths group, there are 2 big books within maths group which can be arranged within them in how many ways? 2 factorial ways. So how many are the total ways in which all the books can be arranged? That would be 3 factorial, okay, multiplied by history book arrangement, science book arrangement, maths book arrangement. 3 factorial is what? 3 into 2 into 1 multiplied by again 3 factorial, 3 into 2 into 1 multiplied by 4 factorial, 4 into 3 into 2 into 1 multiplied by 2 factorial, 2 into 1. What do we get? 3 2s are 6, 3 2s are 6, 4 3s are 12, 12 2s are 24 into 2. That would give us 1728 ways. So in 1728 ways, books can be arranged so that all the books of same subject are together. See how easy it was. You just need to remember n books can be arranged in n factorial ways, right? And when we make groups, the groups remain together. When we make groups, whatever material is there within the groups, okay, that will always remain together. And within a group also we can make arrangements, we can separate. For example, these 3 books are 1, 2, 3 and these are the 2. these are the other two groups. Okay, now this 1 2 3 can be written as 1 3 2 also. We can arrange it as first book, third book and second book of history. Again we'll have this same, okay, and we can keep on changing, right? So within group also there is arrangement, and between the groups also there is arrangement, right? So we have to consider both these things. Again, when we solve more and more sums, it would become very much clearer to you. Now moving to question number 2. Question number 2. In how many ways can we arrange the word fuzz tone so that all the vowels come together? Again, we have the word arrange over here. Arrange is related to factorial, that is n factorial. Okay, there is no select, and arrange. Only arrange is there. What is the word they have given? Fuzz tone. Okay. Now they want that all the vowels come together. We have to arrange it in such a way that in how many ways we can arrange that all the vowels always come together. What are the vowels? U, O and E. These are nothing but the vowels. That means there are 3 vowels, right? How many total words are there? How many total words are there? There are total 8 words, right? There are total 8 words. Out of that, 3 are vowels. So how many left? 5 alphabets left. Okay, there are actually 8 alphabets, right? So 5 alphabets are left, right? Now what are the 5 alphabets? F, Z, Z, T, N. Okay, now these 3 vowels have to be together compulsorily. So consider this as one group. Just like we saw in the last sum, we want history books to be together, maths to be together, science to be together. So we consider everything as a single separate group. So these 3 vowels always have to be together, always should come together. So consider the vowels as a single group. Now these vowels can be arranged within themselves in how many ways? 3 factorial ways. Why? We have seen that history books, there are 3 history books, and within themselves, within the 3 history books can be arranged in 3 factorial ways. Same way, these 3 vowels within the group can be arranged in 3 factorial ways. Now after we consider these 3 vowels as one group, we are left with 8 alphabets minus 3 vowels, that is 5 alphabets. So these 5 alphabets plus this one group will make total as 6. Okay, so we'll have 6 things. These 5 things plus this one thing. So we'll have 6 things. These 6 things can be arranged in how many ways? 6 factorial ways. We have already learned if there are n things, we can arrange them in n factorial ways, right? So these 6 things can be arranged in 6 factorial ways. So what you can say directly is that these 6, so the final answer in how many ways we can arrange is 6 factorial into 3 factorial. But no, that is not the answer. Why? Let us see. Now over here, if you observe carefully, what do we see over here? We have F, we have Z, we have Z, we have T, and we have N. Z gets repeated twice. So this is duplicate, this is duplication. There are 2, there is an alphabet which is getting repeated twice. Okay, how to handle such things? It is very easy. Take a look on the right hand side, you will understand it. Okay, if say we have n alphabets or n digits or n things, okay, if we have n things, out of that one thing gets repeated say 4 times, okay, or we can say if there are n alphabets and out of that one alphabet gets repeated 4 times, then how many ways we can arrange these n things? We already know that n things can be arranged in n factorial ways, correct? But one alphabet or one thing is getting repeated 4 times. So how to arrange these repetitions? Very easy. How many times does it get repeated? 4. Simply write 4 factorial. So over here we have 6 things. Out of that, one alphabet, that is Z, gets repeated twice. That means Z appears how many times? Z appears once and twice, 2 times. So total number of ways in which we can arrange these 6 things are 6 factorial upon Z appears 2 times. So 2 factorial. If Z would have appeared 3 times, we would have written 6 factorial upon 3 factorial. Okay. So now we can have the final answer as 3 factorial into 6 factorial upon 2 factorial. That would be 3 into 2 into 1 multiplied by 6 into 5 into 4 into 3 into 2 into 1 divided by 2 into 1. Now, take a look carefully over here. What have we written? We have written 3 factorial into 6 factorial upon 2 factorial. What is 2 factorial? 2 into 1. Here also what we have 3 into 2 into 1. So we can write this as very easily 3 into 2 factorial. Okay, though it is not useful over here, anyways this gets cancelled over here, but always remember this trick, because whenever the values are greater like 6 factorial, 7 factorial, 8 factorial, while division you can use this trick. You can write 6 factorial as nothing but 6 into 5 into 4 factorial or 6 into 5 factorial, like that. So that would help you to reduce the calculations. Okay, so right now this gets cancelled over here and the answer to this comes out to be 2160 ways. Okay, the answer is 2160 ways. So in 2160 ways we can arrange the word first tone so that all vowels come together. Moving to next question. Question number 3. If Suraj doesn't want vowels together, then in how many ways can he arrange the letters of the word marker? Again, this is very easy. If you have seen the probability video, okay, then you will be able to solve this in a jiffy very quickly. But even if you have not seen the probability video, no problem. We'll learn again over here how to solve these kind of sums. It is very easy. It is related to our question number 2. Let us see. What have we learnt in question number 2? That whenever we want the vowels together, what we should do, right? Now over here, what they have? They have the word marker. Which are the vowels over here? A and E. So there are 2 vowels, right? How many letters are left? Total is 6 letters. Out of that, 2 are vowels. So 4 letters are left. What are the letters? M, R, K and R, right? Now, what do they want? They do not want the vowels to be together. So, how to find out the vowels should not be together? Very easy. Total number of ways in which we can arrange the words, okay, is nothing but the ways in which we can arrange so that the vowels are always together, okay, vowels are always together, plus the ways in which vowels are never together, right? It is very simple. Total number of ways in which we can arrange all the letters of this word marker is simply the number of ways in which we can arrange so that the vowels are always together, plus number of ways in which we can arrange so that the vowels are never together. This is what we had seen in the probability video also. Please remember, it is very easy. There is nothing much or complicated over here to understand or to remember. It is very easy. Just remember, total ways in which we can arrange a word or this is nothing but a total number of ways in which the vowels always together and total number of ways in which vowels are never together. So total number of ways in which vowels are never together will be nothing but total ways, okay, total ways minus the number of ways in which the vowels are always together, right? Total ways is how much? How many letters are there in the word marker? 1, 2, 3, 4, 5, 6. So total ways are 6 factorial? No, it is not 6 factorial. Then what it is? It is 6 factorial divided by, here you see the word or the letter R gets repeated 2 times. So 6 factorial upon cancelling the repetition, 2 factorial. This is the total number of ways in which we can arrange the letters of the words marker. That is nothing but that comes out to 360 ways. Now let us find out the total number of ways in which the vowels are always together. This is like the sum number 2 which we have seen, right? So vowels are always together. How to find vowels are always together? Make the vowels as one group. So the 2 vowels become one group, right? And the 2 vowels of the group can be arranged in 2 factorial ways, correct? Now when we make it as one group, what are we left with? 6 letters minus 2 vowels are 4 letters. So we have 4 letters plus one group, that would be 5 things. These 5 things can be arranged in 5 factorial ways. No, not 5 factorial. Why? Because 4 letters are M, R, K and R. R gets repeated twice, that is 2 times. So answer is these 5 things can be arranged in 5 factorial divided by 2 factorial, because we are cancelling the repetition, right? Now this is the way to arrange 4 letters and 1 group. Plus in the group we can arrange it in 2 factorial ways, we have already seen. So the total number of ways is 5 factorial, right? 5 factorial is nothing but 120 ways. So the ways in which vowel can always be together is 120. Total ways is 360. So the answer would be nothing but 360 minus 120, that would be 240 ways. So in 240 ways we can arrange the letters of the word marker so that the vowels are never together, right? See how easy it was, there is nothing to it, very easy sum, right? So you just needed to remember that total ways is nothing but vowels always together plus vowels never together. If you know this, you will be able to solve the sum. Many of the sums rely on these kind of small common sense and common logic tricks to solve the sum. Okay, now moving to next question. Question number 4. Without repetition, using digits 2, 3, 4, 5, 6, 8 and 0, how many numbers can be made which lie between 500 and 1000? Again, this is an easy sum, and in this sum we are going to see 2 methods, okay, 2 ways to solve this sum. One is by the formula, right? One is by the formula and other is by logic or the common sense, okay. Now first let us solve it by formula, right? Or let us solve by logic first, okay, let's take logic first. Now what is given over here? Without repetition, so repetition should not be there, and we have to make numbers which lie between 500 and 1000, okay. So number has to be 3 digit, 1, 2 and 3, because we want a number which is between 500, that is more than 500 and less than 1000, okay. Now how many what possible choices are given? 2, 3, 4, 5, 6, 8 and 0. Now out of that, if we see, if we take the first digit of the number as 2, will it lie between 500 and 1000? No. 3, if we take it as 3, no. If we take it as 4, no. If we take it as 5, yes, possible, because 501 to 599 lies between 500 to 1000. So we can have here we can have 5, we can have 6, we can have 8. You cannot have 0 over here because it does not lie between 500 and 1000. So how many choices are possible over here? There are 3 choices possible, okay. What are the choices? 5, 6 and 8. Now here 3 choices are possible. Since they have given that there should not be repetition, okay, that means that total numbers, how many are these total numbers? 2, 3, 4, 5, 6, 8 and 0. Total are 7, okay. 7 numbers are there. Out of that, 1 number gets utilized over here. Whichever number it is there out of 5, 6, 8 doesn't matter, but 1 number gets utilized. So how many are remaining? 7 minus 1, remaining are 6, okay. Now here anything can come, because now we have already know that it should be greater than 500. We have already chosen numbers which are related to, which will make the number greater than 500. So all the possible numbers can come over here, okay. So how many out of 7, since there is no repetition, we have already used 1 number, okay. So how many digits are remaining? 6 digits are remaining, right? So here 6 possible choices are there. Out of these 6, any one can come over here. Again, 1 has been utilized, correct. How many possible choices remain now? 5. So there are 5 possible choices over here. So condition was 500 to 1000. So we did not take 7 over here. We took directly only 3, because only 3 numbers, 5, 6 and 8 will make sure that our final answer or all the numbers which we form will lie between 500 and 1000. So the possible choices we have put in here. 3 choices can come. Here 6 digits can come, any of the possible 6 digits. Here any of the possible 5 digits can come, okay. So what is the final answer? How many possible numbers are, how many numbers are possible? 3 into 6 into 5. 3 6 are 18, 18 5s are 90. This is the answer, okay. This is the answer because there is no repetition. If they say repetition is allowed, what will be the answer? Let us see. Repetition is allowed, okay. First we want the number between 500 and 1000. So there are 3 possible choices again over here, 5, 6 or 8, okay. Second number, third number. Now even if we use 1 number over here, still repetition is allowed. So again we have the entire set, that is 7 possible choices over here. Again, even if we use one number, two numbers over here, we can, repetition is allowed. That means if we take 5 at start, then 5, 5, 5 is allowed. Initially over here 5, 5, 5 was not allowed. Why? Because repetition was not allowed. But over here 5, 5, 5 is allowed in second case. So again at the last we will have 7 possible choices. We can take any number. So the answer will be 7 7s are 49, 49 into 3, okay, or 21 into 7, that would be 147, okay. But we don't want repetition over here, so our answer is 90. So have you understood what exactly it means by repetition and how by logic we can solve such kind of sums? Now let us move on to the second method, okay. Second method is formula based method, okay. Now second method, it is similar, right? 3-digit number we have to form, correct? Now the first digit, right? It can be 5, it can be 6, or it can be 8. So there are 3 possible choices. Out of these 3 choices, we have to select one digit to put over here. So 3 choices are there. We have to select one digit. Select means combination. So we have C. Now please remember, whenever they are saying that using these digits form a number, okay, whenever they are saying that use these digits or select these digits, directly you should mention combination, okay. Here again there are 3 possible choices, 5, 6, 8. Out of that we have to select one digit and put over here, okay. So select is combination. So we have 3C1 multiplied by, here again one digit has already been used. So there are 6 possible choices. So out of 6 we have to choose 1. Out of 6 we have to select 1. So 6C1, right? And out of 6 again one digit is used in this place. So over here only 5 digits remain. Out of 5 we have to choose 1. Choose means select. Select means combination. So answer is 3C1 multiplied by 6C1 multiplied by 5C1. What is it? What is 3C1? It would be 3 factorial upon 1 factorial multiplied by 3 minus 1 is 2 factorial multiplied by 6 factorial, 1 factorial, 6 minus 1 is 5, 5 factorial multiplied by 5 factorial, 1 factorial multiplied by 4 factorial. Now 3 factorial can be written as, we will write it over here, 3 into 2 factorial divided by 2 factorial, that gets cancelled. Same way 6 factorial is 6 factorial into 5 factorial, that gets cancelled. So we get 6 over here. 5 factorial is 5 into 4 factorial, 4 factorial, 4 factorial gets cancelled. We get 5 over here. We get it as 90, okay. 3 into 6 into 5 is 90, just like the previous answer. So you can go any way. You can go by the formula also, you can go by simple logic also. It is best to develop both the areas, because some sums you can solve very quickly using logic, some sums you can solve very quickly using formula, okay. Moving to next question. Question number 5. 4 members form a group out of total 8 members. Point 1. In how many ways it is possible to make a group if 2 particular members must be included? Point number 2. In how many ways it is possible to make the group if 2 particular members must not be included? Now here there are 2 sub questions, okay. Now earlier we saw how to solve the sum using logic also and formula also. You might have thought that using logic it is faster, there is no need to use formula, but over here I will show you how formula is also very useful and it is very important to learn it. Let us see, what are they saying? There are total 8 members, right? There are total 8 members. Say let the members be A, B, C, D, E, F, G and H, okay. These are the 8 members. Now in how many ways it is possible, the sub question 1, okay, sub question 1, in how many ways it is possible to make a group of 2 people if to make the group if 2 particular members must be included. They already say that the group must be of 4 members, right? At the start they say 4 members must be in the group, but the condition in the first case is that 2 particular members must be included always, correct? Let us assume that member C, okay, member C and member F, both these members have to be included compulsorily, okay, they must be included, right? So 2 places have been occupied by these. How many places are remaining? Now 8 places, right? There are 4 places in a group. So 4 members can form a group. That means there are 4 places in a group. Out of that, 2 places are already occupied by C and F. So out of 4 places, 2 places are occupied. So only 2 places remain. That means you can select only 2 members now. Okay. Total members are how many? 8 are total members. But out of that, we have already selected 2 members. Those have to be included compulsorily. So how many remaining members are there? 1, 2, 3, 4, 5 and 6. So out of the 6, so 2 members are already selected. So 6 members remain. Okay. And we have to fill these 2 remaining places using only these 6 members. Here we have to make the group. That means we have to choose people to form the group. That means we have to select people to form the group. And select means combination. Okay. Combination. That means we have 6 people remaining. Out of that, using these 6 people, we have to fill the remaining 2 seats. We have to choose 2 people out of 6. We have to select 2 people out of 6. So it would be 6 factorial upon 2 factorial into 4 factorial. That would be equal to 6 into 5 into 4 factorial divided by 2 factorial into 4 factorial. This gets cancelled. 2 factorial is nothing but 2. 2 3s are. Answer would be 15. There are 15 ways, okay, in case of point number 1 or question number 1, okay. Now let us take the question number 2 or case 2. Here they are saying that 2 particular members must not be included. Let us assume that now over here C and F must not be included at all in the group, okay. How many members are remaining? Total there are 8 members. Out of that, 2 must not be included. So 6 members remain again. Okay, 6 are remaining. So whatever group we have to form out of these 6 members. They have given that the group has to be formed, but C and 2 members, that is C and F, must not be included at all. 2 particular members must not be included at all. So we have to fill the 4 vacancies which are there in the group using these 6 people. So there are 6 people. We have to fill 4 vacancies. That is, we have to choose 4 people, that is select 4 people. Select means combination. So number of ways is 6 factorial divided by 4 factorial multiplied by 2 factorial. That will again come out to 15 ways. So both the answer for both of them is 15 ways. Okay. So see how easy it was using the formula. This is, since I am explaining, it might have taken time, but using the formula you can simply write 6C2. Okay, need 2 places, only 2 people should be considered out of 6. So 6C2 you will get this answer. 6C4 you will get the answer as 15 ways. That is done. You will be able to solve combination problems. If you practice, you will be able to solve combination problems in 45 seconds to 1 minute very easily. Just remember when to use logic, when to use formula, and with practice you will be able to get a grasp of this. It is very easy. Moving to question number 6. There are 8 routes from London to Delhi and there are 6 routes from Delhi to Tokyo. In how many different ways can Raj travel from London to Tokyo via Delhi? Now over here again we can solve this by common logic. It is extremely easy sum. Let us see how. London, Delhi, Tokyo. There are how many ways from London to Delhi? 8. How many ways from Delhi to Tokyo? 6. Okay. In how many different ways can Raj travel from London to Tokyo via Delhi? Very easy. Let us assume that Raj, say there are 8 ways, like 1, 2, 3 up to 8. Then Delhi to Tokyo, again there are 1, 2, 3, 6 ways. Okay. Let us say that Raj first takes way number 1 from London to Delhi. Okay, London to Delhi, right? When he reaches Delhi, for way number 1, how many options are there for going Delhi to Tokyo? There are 6 options because there are 6 ways, right? So for road number 1 or way number 1, he has 6 choices to go from Delhi to Tokyo. Same way, if Raj takes the second way and reaches Delhi, okay, and reaches Delhi, again from Delhi to Tokyo, how many choices he'll have? Again 6 choices he'll have. He can go by any way, right? So for every 8 way, all the ways in this from London to Delhi, Raj will have 6 choices. That means for 8 ways of London to Delhi, for each way Raj will have 6 choices. That is totally 48 choices would be there with Raj, and this is nothing but the number of different ways in which Raj can travel from London to Delhi and London to Tokyo via Delhi. You can count it. Let us see how. For first way 6 choices, second way 6 choices. Okay, I'll write over here. For first way from London to Delhi, there are 6 choices from Delhi to Tokyo, and this is London to Delhi. For second way 6 choices, third way 6 choices, fourth way 6, 5, 6, 7, 6. For the eighth way also 6 choices. How many different ways are possible? 1, 2, 6 into 8, 48. That is what we did, 8 into 6. See how easy it was. Moving to next question. Question number 7. There are 35 people in a group. There are 12 schoolgirls, 10 schoolboys, 5 senior citizens and 8 babies in the group. The organizer of the group wants to select a schoolgirl or a schoolboy as leader of the group. In how many ways can he do so? Again, it is very easy. Again, we can solve it by 2 ways. We'll see both the ways of logic and formula. Okay, very easy, both are easy. Now, first we'll see formula this time. Okay, now formula. Now he wants to select a schoolgirl or a schoolboy as leader. Okay, how many leaders does the person want? Person wants one leader. Person wants to select one leader. So this is nothing but value of R, because we select R things out of N. Okay. Now the leader wants to select one. The organizer wants to select one leader. That is R is 1 out of whom? Out of a group of 35 people. But here N will not be 35. Why? Because the organizer does not want any one leader. The organizer wants a leader only who is a school girl or who is a school boy. Okay. So total number of people, school girl is 12, school boy are 10. So out of these 22 only, okay, school girl or school boy, only out of these 22, the organizer want to select one leader. So N is nothing but 22. We have to select R things out of N. So we have to select one leader out of these 22 only. We don't want 35 people, because 35 people includes 5 senior citizens and 8 babies. But the leader should be from school, should be a school girl or a school boy. So we want to select one leader from 22 people, right? So what, since we have to select, what we'll do? Selection means C. We have to select R people from N things, R things from N things. That is 22 C1, 22 factorial upon 1 factorial into 22 minus 1 is 21 factorial. That would be 22, right? Now let us see by logic. Okay, this is by logic. How many schoolgirls and schoolboys are there? 12 schoolgirls, 10 schoolboys. So 22 people are there. Out of these 22 people, we want just one leader. If you want one leader, how many choices do the organizer have? They have 22 choices. They can choose any one from these 22. Okay, we will not consider senior citizens and babies because the organizer wants a schoolgirl or a schoolboy as leader. So we will consider only 22 people. So out of 22 people, we want one leader. So the people, how many choices are there for this position, this vacant position of leader? There are 22 choices with the organizer. So answer is 22. See, with logic also we got the same answer. Now if they would have said that the organizer of the group want to select one person as leader of the group, then we can simply say we want one leader. Okay, this vacant position of one leader has to be selected. How many possible candidates are there? 35 choices are there, because there are 35 people and there is no criteria that schoolgirl should become a leader or schoolboy should become a leader or a baby should become a leader. They just want one person as leader of the group. So 35 choices are there, but over here we will not consider 35. That was just an extension to explain what you are doing over here. We just want that the leader should be schoolgirl or schoolboy. So the answer is 22 ways. Moving on to next question. Question 8. In a class there are 15 students. During a Christmas party, all of them shook hands with each other only once. How many handshakes took place in the class? Now this is one of the most famous examples which are asked in every exam. Please remember how to solve this kind of sum. It is extremely easy. Okay, this is a permutation combination sum. Actually, specifically it is a combination sum. Okay, very easy sum. and a very easy formula or a very easy trick to solve this sum. I'll also explain in what format this sum can be asked. Now over here they are saying that there are 15 students. So total number of students are 15. N. Okay. Each student shook hand with the other person only once. Only once. This is important. Okay. How many handshakes took place in the class? Very easy. There are 15 students. Okay. For a handshake, how many students do we need? We need 2 students for a handshake. Okay. So if you want to make an handshake, we have to select 15 students out of, we have to select 2 students out of 15. Select means combination. Select 2 students out of 15. This is the answer. What do we get? 15 into 14 into 13 factorial upon 2 factorial into 15 minus 2, 13 factorial. That would be 15 into 14 divided by 2, 105. 105 handshakes take place in the class. Very easy. Answer is what? 15C2. What is 15? Total number of students. What is 2? 2 will always be there. Why? For an handshake, 2 people are needed. So 2 will always be there. Only thing changes is this. If they give you, if there are 30 students in a class and they shake hands with each other only once, what will be the answer? It would be 30 students are there. So 30C2. And find the answer like this. Very easy. Nothing to it. Just remember answer is 15C2. Okay. Or NC2, where N is number of students. Now, in what way can this question be asked? They can say that there is a cricket league or a football league, and there are say 9 teams in the football league or the cricket league, and each team plays match with other team only once. Only once. This is very important. Only once. Then how many matches are played in the league? Simply, how many teams are there? 9. 9C2. This is similar to handshakes. For playing a match, 2 teams are needed. So selecting 2 teams out of 9. 9C2. What you'll get? 9 into 8. This is 9 factorial upon 9 minus 2 is 2 factorial. 9 minus 2 is 7 factorial. That would be 9 into 8 into 7 factorial. That gets cancelled. 2 factorial is 2. 2, 4, 9 4s are 36. 36 matches get played. Very easy. Now again, I'll go a little bit further. If they say, okay, if they say that in a class there are 15 students and during a Christmas party all of them shook hands with each other, only that much is given. Only once is not given. How many handshakes took place? Then what you can say over here is that 105 handshakes take place when each of them is shaking hand with the other person only once. Okay. But if only once criteria is not there, then there is a chance that each person can shake the hand twice, because say if there is A and there is B, A can shake hand with B, and then when B's turn come, B can also shake hand with A. So for both the people, 2 handshakes happen. So over here what we can have? We will have 105 when it is only once. Simply multiply by 2, you will get 210. But mostly this is not asked. Only they asked how many of them shook hands with each other only once. Okay. Only once is there. Most of the time go with only once, and the answer is 15C2. Remember, it is 15C2, NC2. Very, very easy. Moving to next question. A bank has 6-digit account number with no repetition of digits within a account number. The first and last digit of the account numbers is fixed to be 4 and 7. How many such account numbers are possible? Very, very easy sum. Let us take a look. Account numbers are 6 digits. Okay, 4, 5 and 6. Out of that, they have given first and last digit of the account number is to be 4 and 7 compulsorily. So these are completely useless for us. Why? Because first and last digit is fixed, so we have no choice. So just consider only the middle 4 digits. What have they said is that there is no repetition of digits, right? How many digits are there in mathematics? If we see single digit numbers, how many are there? There are not, since it is a 6-digit number, single digit numbers are 10. How? 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, out of that 4 and 7 already we used, and since there is no repetition, we cannot have 4 and 7 over here. How many are left? Out of these 10, when we remove these 2, how many are left? 8 are left. So here we have 8 choices, correct? The second digit of the account number, we have 8 choices over here. 0, 1, 2, 3, 5, 6, 8, 9. Out of that, again, 1 digit gets over here at the second digit. Okay. So how many choices are left over here? 8 minus 1, 7 choices are left. Okay, again 1 digit gets over at this place. So how many choices are left? Only 6 digits are left. Because why 6? Because out of 10, here 1 digit is taken, here 1 digit is taken, here 1 digit is taken, here 1 digit is taken. Again this place, okay, 5 digits are already taken. How many are left now? How many choices are there? Out of 5 we have to choose a digit. So what are the total possibilities or possible account numbers? 8 into 7 into 6 into 5 would be equal to 8 7s are 56, 6 5s are 30. That would give us 1680 account numbers. Okay, 1680 account numbers are possible with the given conditions. Moving to question number 10. A trekking group is to be formed having 6 members. They are to be selected from 3 girls, 4 boys and 5 teachers. In how many ways can the group be formed so that there are 3 teachers and 3 boys, or 2 girls and 4 teachers? So they are giving us 2 options, that there are 2 kinds of groups that are to be formed. Okay, what they are saying is that the group which is to be there, it can either have 3 teachers and 3 boys, okay, or you can have a group which has 2 girls and 4 teachers, right? See, in probability, we have in the probability video, if you have not seen, please take a look at that. Over there we learnt a very easy concept and very small concept. Please remember it, it is useful. And means multiply, or means addition, that is add. Okay, if you remember this, you will very easily be able to solve this sum using formula and this basic concept. And means to multiply, or means to add. Okay, now over here we want either 3 teachers and 3 boys, or we want 2 girls and 4 teachers. Now how to select 3 teachers? Okay, we want, how many teachers are there? There are 5 teachers. Out of that we have to select 3 teachers. Select means combination. 5 factorial upon 3 factorial into 5 minus 3 is 2 factorial. That would give us 10 ways, okay, to select 3 teachers. Okay, then 3 boys are there. How to select 3 boys? How many boys are there in total? 4 boys. Out of that we have to select 3 boys. Select means combination. 4 factorial upon 3 factorial into 4 minus 1. 4 minus 3 is 1 factorial. That would be equal to 4 ways. Okay, and we know that we have 3 teachers and 4 boys. So 10 ways, and means multiplication. 4 ways would give us 40 ways. Okay, now this is or means addition. Okay, we have 40 ways over here. Or means addition. We want to select 2 girls. How to select 2 girls? How many girls are there? 3 girls. Out of that we need to select 2 girls. Select means combination. 3 factorial upon 3 minus 2 factorial is 1 factorial into 2 factorial. We will get answer as 3. Okay, then these are 3 ways. We also want 4 teachers out of 5 teachers. So 5 teachers are there. Select 4 teachers. That would give us, again the answer would be 5 ways. Okay, so select 2 girls and select 4 teachers. So total number of ways would be 3 into 5 ways, 15 ways. So in 40 ways we can select 3 teachers and 3 boys, or we can go for 15 ways where we select 2 girls and 4 teachers. And or means addition. So add these two, what do we get? 40 plus 15 equal to 55 ways is the answer. See how easy it is, very easy. Just remember, and means multiply, or means addition. This would be useful in probability also. Okay, and means multiply, or means addition. Moving to question number 11. On a railway line there are 20 stops. A ticket is needed to travel between any 2 stops. How many different tickets would the government need to prepare to cater to all possibilities? Very easy. Let us see. This is a railway line. Okay, this is the start point A, this is the end point B. Okay, this is the first stop, this is the 20th stop. So second, third, fourth, fifth, sixth, like this there are 20 stops. If you want to go between any 2 stops, like this to this, or say this to this, or say here to here, or even here to here, then you need a ticket. So how many different type of tickets would the government need? Very easy to find out. How many stops are there? 20 stops are there. Now if you want to travel, okay, between 2 stops, okay, if you need a ticket is between how many stops? 2 stops. Okay, if you want to travel from first stop to the second stop, or one stop to other stop, or one stop to second stop, then you need a ticket. So ticket is needed for between any two stops. So that means it is simply we have to select two stops out of 20 stops. This is R, this is N. Select means combination. Select two stops out of 20 stops. What is that? This is 20 factorial upon 2 factorial into 18 factorial. 20 into 19 into 18 factorial divided by 2 factorial into 18 factorial. This gets cancelled. 10, 190 possible tickets. But this is not the answer. Now you will say why? Because this 190 is when we are starting from here, when we are going from here. Now if say this and this, okay, you want to travel from here to here, you will buy a ticket. Will you use the same ticket to travel from here to here? No. If you want to travel from this stop to this stop, there will be a separate ticket for this, right? So 190 tickets are from one side while traveling from one side. Again, while traveling from other side, we will have same plus 190 tickets. That would be 380 is the answer. 380 possibilities are there. 380 possible tickets are to be made by the government. Moving to the next question. 17 students are present in a class. In how many ways can they be made to stand in two circles of 8 and 9 students? Again, very easy. There are two things that I would like to explain over here. The first thing is that here the students are not made to stand in a straight line. Okay, they are made to stand in a circle. And the second thing is that we already know if we have n things, if we want to arrange them in a circle, that can be done in n minus 1 factorial. If you want to arrange them in a straight line, we do it in factorial ways. If you want it in a circle, we can do it in n minus 1 factorial ways. Okay, very easy. Let us see how to solve this sum. There are 17 students, okay, and we need two circles, okay, two circles. One of 9 students, one of 8 students, right? 9 plus 8 is 17. That means that what we will do is first we will select 9 students out of 17 and arrange them, and the remaining students will arrange over here. As remaining are 8 students only, we can arrange it in this circle. So first what we need to do, select 9 students. Select means combination. We have to select 9 students out of how much? 17 students. What do we get? 17C9. Okay, let's not solve it right now. Okay, this is 17C9. That is, we have selected these 9 students. Now these 9 students will be arranged in a circle. In how many ways? Very easy. N minus 1. So 9 minus 1 factorial would be 8 factorial ways. Correct? So these students would be arranged in 8 factorial ways, right? Now how many students are remaining? 17 minus 9 is 8. These 8 students will form a circle of 8, okay, which they have given, okay, the second circle. These 8 students would be arranged in how many ways in a circle? 8 minus 1 factorial ways. That would be 7 factorial ways. So what are the total number of ways? 17C9 multiplied by 8 factorial multiplied by 7 factorial. You can keep this as answer, or you can simplify it as 17 factorial divided by 9 factorial into 8 factorial into 8 factorial into 7 factorial. So you get this, you will have 17 factorial into 7 factorial divided by 9 factorial. Okay, now when there are values like this, keep the answer like this only. Don't try to calculate, because 17 into 16 into 15 into 14 would be really huge. So in options you will get similar kind of answers, okay, similar kind of options. So tick the appropriate option. Now if we can do it other way also. We can have 17 students and we can select 8 students. Let us see. We have 17 students and we will select 8 students first and arrange them in a circle. Selecting 8 students is 17C8, okay. Arranging them in a circle is 8 minus 1 is 7 factorial. How many students remain? 17 minus 8 is 9. This is 17. 17 minus 8 is 9. These 9 students can be arranged in a circle in 8 factorial ways, right? So what is the answer we will get? 17 factorial divided by 8 factorial into 9 factorial into 7 factorial into 8 factorial, same as this, okay. So we will get the same answer as this. Now over here what is happening is that the students have to be arranged in a circle, right? Two circles. Had the students been to arrange, if they say that take 17 students and arrange them in a straight line, you can directly use the permutation formula. What is the permutation formula? NPR is nothing but n factorial upon n minus r factorial, right? Permutation formula is derived from combination formula, right? We have n factorial upon r factorial into n minus r factorial, and arranging is r factorial, so r factorial gets cancelled and we get this formula. So what we can do is, we will have NPR equal to n factorial upon n minus r factorial, okay? So if we want to arrange students, 17 students in two lines of 8 and 9 students, then what we'll do, we'll simply take this permutation formula, okay? Let's solve over here at the bottom. We'll take this formula, 17 students are there, we have to arrange it into two lines. So let us assume we select 9 students first, okay? So we'll have 17 factorial divided by 17 minus 9 is 8 factorial. Okay, this is the arrangement of 9 students in single line. Now arrangement of 8 students in single line is 8 factorial. This gets cancelled, answer comes out to be 17 factorial. Okay, so we can use permutation formula also if we have to arrange it in a single line, but here we want a circle. So what we did, we just selected and then arranged in circle, selected, arranged in circle. Okay, very easy. Most of the permutation sums you can solve by selection and then arranging. Okay, that would become easier and logical if you are not able to remember the permutation formula. Moving to next question. A locker in bank has 3-digit lock. Mahesh forgot his password and was trying all possible combinations. He took 6 seconds for each try. The problem was that each digit can be from 0 to 9. How much time will be needed by Mahesh to try all the combinations? Okay, now here they have given each digit can be 0 to 9. That means repetition is allowed. Okay, repetition is allowed. It has a 3-digit lock. Okay, and each of the digit can be from 0 to 9. That means there are 10 possibilities. 0 to 9 are 10 digits. So 0 to 9 can come over here, anything, 10 possibilities, again 10 possibilities, again 10 possibilities. How many are the total possible combinations? Just multiply. 1000 combinations are possible. For each combination, Mahesh takes 6 seconds. So total seconds taken is, each possible combination 6 seconds. Okay, 1000 are possible, so he'll take 6000 seconds. That is nothing but divided by 60. What you will get? 100 minutes, right? So Mahesh will take 100 minutes to try all the combinations. Moving to next question. In a room, there are 2 green chairs, 3 yellow chairs and 4 blue chairs. In how many ways can Raj choose 3 chairs so at least 1 yellow chair is included? Again, very similar to what we had seen in probability as well as earlier here on. Here they have given what? Raj needs to choose 3 chairs and at least 1 yellow chair should be there. At least 1 yellow chair means what? At least means there can be 1 yellow chair or 2 yellow chair or 3 yellow chairs. So you can find out the combination for all these and then we can add, or we can do another method. What is it? Total ways are nothing but choosing yellow chair, okay, choosing at least 1 yellow chair plus choosing no yellow chair, okay, choosing 1 yellow chair, okay, and choosing no yellow chair. So what is at least, what are the number of ways for choosing at least 1 yellow chair? That would be total ways minus choosing no yellow chair. What are the total ways? What are the total chairs over here? There are 2 green, 3 yellow and 2 green plus 3 yellow plus 4 blue chairs. That will 4 plus 7. Total 9 chairs are there. How to choose 3 chairs from 9 chairs? Very easy. Select means combination. Select 3 chairs from 9 chairs. That would be 9 factorial upon 3 factorial into 6 factorial. That is 9 into 8 into 7 divided by 3 into 2. This comes out to be 4, 3, 84 ways. Okay, these are the total number of ways. 84 are total number of ways. Now, how many ways in which we can choose not a yellow chair, or we should not choose even a single yellow chair? How many non-yellow chairs are there? 2 green and 4 blue. That is 6 non-yellow chairs are there. Non-yellow chairs are there. Out of these 6, we have to choose 3 chairs. 6 factorial upon 3 factorial into 3 factorial. That would be 6 into 5 into 4 upon 3 into 2. 2 2s are 3 2s are 20 ways. Okay. So in 20 ways we can choose a non-yellow chair. So total number of ways in which we can choose at least one yellow chair is nothing but total ways minus ways for choosing no yellow chair. 64 ways is the answer. See how easily by using this method which we have seen in probability also, and right now in few sums, before few sums also we have used this technique, we can solve the sum. Moving on to question number 15. How many combinations are possible while selecting 4 letters from the word smoke jack with the condition that J must appear in it? Again, very easy sum. Let us take a look how to solve this. What are they saying? We want a 4-letter word, or we have to select 4 letters. Out of that, J has to appear. That means one place is already occupied by J. Okay. Now, so we have to select only 3 letters. Also, out of smoke jack, J already has been occupied, so we cannot select J again. So what are we left with? SMOKEACK. Okay. So we are left with 5, 8 letters. We are left with 8 letters. Out of that, K is repeated twice. Okay. K comes 2 times. Right. Now, what to do? Now we have to select 3 letters. There are 3 possibilities that can happen. What can happen is that you can have both the K's and you just need 1 letter over here. You can select 2 K's and you just need 1 letter over here. Once you select 2 K's, so these 2 K's will go out of commission. You cannot select them. How many are left? 1, 2, 3, 1, 2, 3, 4, 5 and 6. Out of these 6, 1 will come over here. That means there are 6 choices, or we can write this 6 as nothing but select 1 letter from 6 possible combinations. Correct? Right? What is the second possibility? That you include only 1 K. Okay, at any of these places you include only 1 K. Now you need not include K over here or over here, because it is not selection and arrangement. It is only selection of 4 letters. So you can select K for any of the place, it doesn't matter. Okay, only selection means combination, right? We select 1K and these 2 places can be filled in. How? We have to fill 2 places and we have to select these characters from where? From the remaining 6, because we are here considering only 1K. We are not going to select the other K. So we will not consider the other K over here in this 6. Okay, these 6 will only include S, M, O, K, A, E, A and C. These 2 Ks will not be included. Out of that, out of the 2 Ks we have already included one, other one will not include. That possibility has already been covered over here. Okay, so these 2 can be filled in 6 C2 ways. Okay, what is the third possibility? This is the first possibility, or this is the second possibility, or okay, or the third possibility is what? Do not consider K at all. Okay, how to fill these 3 places using 6 characters? 3 places selected from 6 characters. Why should we not include these K? 2K, because we have tried to include these possibilities over here. So over here we are considering a possibility where K is not included at all. Okay, so without including K, how many letters are there? 6. Out of 6 we have to select 3. Okay, so what are the total possible ways or total possible combinations? 6C1, or we can have 6C2, or we can have 6C3. This is nothing but 6 factorial upon 1 factorial multiplied by 5 factorial plus 6 factorial upon 2 factorial into 4 factorial plus 6 factorial upon 3 factorial into 3 factorial. This would be 6 plus 15 plus 20, that would be 41 ways it is possible to have J, okay, while selecting 4 letters from the word smoke jack. See, we do not need any more formulas, just know the combination formula, just use simple common sense and we can solve the sum, right? you need to remember that permutation and combination is not a tough topic. You just need to remember the formula and little bit of logic. You will be able to solve the sums. Also, if there are n things, we can arrange them in a single line in n factorial ways. If we want to arrange them in a circle, we can do it in n minus 1 factorial ways. Very easy. Formula for combination is what? NCR is, since we have n, so n factorial, here we have r bottom, so we have r factorial, and n is greater than r, so n minus r factorial. Combination also means to select. Now, permutation means, if combination is select, permutation means permutation is nothing but select and arrange. So formula for selection is nothing but same as combination. What is it? R factorial into n minus r factorial multiplied by selection is done. Now arrangement, r things can be arranged in r factorial ways. So this gets cancelled. So what is the formula for for permutation? This is the formula, n factorial upon n minus r factorial. Even if you don't remember formula for permutation, it is fine. If you remember the formula for combination, you can derive permutation formula, because combination is select, permutation is select and arrange. Okay, very easy. Just remember these things. And another important thing, and means to multiply, or means to add or addition, right? Very easy. Just remember the formulas. This is it for video on permutation and combination. I hope this helped you. If you liked it, please give it a like and do share the video with friends. Leave your comments and suggestions for us. You can even leave a request for video on topic of your choice. Also, do not forget to subscribe to our channel to stay updated.